started. So,
Yeah.
Mike, thank you very much for taking time. I would like for you to tell us about yourself. What is it that a little bit about your background and what it is that you're doing right now?
Sure. So I am a professor. Actually, my the term is a professor of practice at Indiana University. That means that I've spent most of my time in industry and have come into the academic world in the last few years. I guess it's been almost 6 years now.
Right.
To teach students. So I'm also the director of the game design program at Indiana University, and I teach a bunch of different courses on things like virtual worlds, artificial intelligence. I actually teach a distance class for Uppsala University in game AI, and then my background, I've been a game developer and game designer since the mid 90s. Started a company then, a software engineer before that.
Hmm.
I've done a lot of work in game design and a lot of work in AI. In the early 2000s, partnered up with DARPA, which is the Defense Advanced Research Projects Agency,
Yeah.
the Mad Scientist Club. Really,
Hmm.
that's what it
Yep.
is.
Yep.
To
A lot of
create,
good stuff's come out of
yeah.
DARPA.
Well, and yeah, for a while I had to go up there every quarter to give our little dog and pony show, and it was great because I always came back with my eyes kind of like this because of all the cool stuff people were doing. But
Yeah.
what I was doing with them, what our team was doing with them, was what we called social AI. We're trying to create agents that could interact socially with people for them for military simulations, but for us for games. And I should say, backing up a little bit more, that came off of me being the lead designer on The Sims 2. Um, I actually worked a
Sims
little,
2.
yeah. So I worked a little bit on The
Wow.
Sims, and
Yeah.
and then was the lead designer on The Sims 2, and was so disappointed in the AI that I said I'm going to go out and make my own company and do the AI the way I want it to be done. Um, I mean, and I should say too, the Sims AI has gotten astoundingly better. They've done a great
Oh.
job with it. Um,
Let's
yeah,
start there. And
sure.
let's do that. So what was the Sims AI and what was some of the underlying technology that was there? What was so awful about
Okay, there's actually some really interesting technology there. On the AI side and on the programming side, and I'll sort of differentiate those a little bit. On the AI side, they used a variant of what's called utility AI, which is
it?
to say, we all have everything in our environment has utility for us. If I'm hungry, food is useful. It has a lot of utility for me. So everything in the Sims environment broadcasts. I satisfy food. A bed, food says that. A chair or bed says I satisfy rest. And so, depending on what the AI wanted, and sort of each sim had its own curves internally. So as you got hungrier, from your point of view, the hunger curve would go up.
Uh-huh.
And so they would choose, oh, I'm hungry, so I'll go get food. Makes perfect sense. And actually, if you just sort of let them run, they work pretty well.
Yeah, yeah, they're
Uh,
very basic motivational system
exactly.
tuned to the I guess the affordances or the things that are out in the real world. Yeah, yeah.
Exactly. Yeah. So the each of the objects had affordances that they broadcast out,
Hmm.
um, and then there were a few oddities, like they had created a visual programming language called Edith, which was really interesting, but also incredibly difficult to use.
Ah,
And there's very programming specific things, like it didn't have it had if then else, but no else if, and that just made for
yeah.
incredibly cumbersome. Um,
Ah,
but the other thing in terms of AI was that the what the Sims would do is say, look around at all the objects I can detect around me,
hmm.
see what they're broadcasting to me,
Hmm.
weight those by how much I want that kind of thing, build up this whole thing, and say, and so now I build up a list of preferences. So
Hmm.
I want to do this, A, B, C, D in order, but then they would look at the top three and choose one randomly, which
Oh,
made
okay.
for some interesting variations in behavior, but also meant, and I've seen this kind of situation where someone has been cooking, a sim has been cooking in the kitchen and catches on fire, a very bad thing.
Hmm.
Another sim says, "I'm hungry," and that's their number three thing is I'm hungry. Number one thing is put out the fire, and number two is go get some rest.
So randomly go which one?
Exactly, exactly. I'm gonna make a sandwich. My friend is on fire, but I'll make a sandwich.
Yeah,
Thing there was
which
this,
which is out of the realm of reality, but not too far out. I mean, I could see like a psychopathic individual doing that, for
Well, it certainly
example.
made for interesting gameplay. That's for sure. There was another one that we codified as what we call the sim slap situation. So you have,
Slap.
yeah.
Okay.
So you have three sims: Al, Betty, and Carl, A, B, and C.
Okay.
Al and Betty are married, so they have an existing relationship that you know about.
Okay.
Carl comes up and slaps Betty. Betty
Okay.
cries because that's her programmed reaction. If I'm slapped, I'm going to cry.
Okay.
Al does nothing at all because because at the time the Sims had no what we call situational awareness. They didn't
Right.
understand anything that was going on unless it happened to them.
Exactly.
Um, and so yeah, I would just sort of stand there, literally like whistle, So when we created our AI, we used a similar architecture in that it was based on a Maslowian or sort of quasi Maslowian model, meaning that we had the basic needs, basic sort of immediate
Hmm.
needs, and then your
Yep.
longer term needs, social needs, skill needs, and contribution
A
needs. A
hierarchical
hierarchy,
list of
yeah,
needs from the basics of food and water all the way up to the self actualization, self
right.
esteem. Yeah. Okay.
And so we modified this and put a lot of nuance into it, so you could have situations where I should say the higher your need for food is,
Hmm.
it inhibits everything else upward. So you,
Yeah.
you really don't
Yeah.
care. So it's like I don't have any friends, but I'm starving. I don't care about
Exactly.
having any friends.
Exactly. Now this is post Sims,
This is
right?
post Sims. This is
And
about
this is
this is go ahead.
around 2000.
2006 7. Yeah,
Right. Okay.
2006
Okay.
2007. Yeah.
Okay.
Um,
Okay.
I mean, it took us a few years to develop this, and we were developing some
Yeah.
other software along the way. But we also had
Yeah.
it where the more your skills were developed, or the more your desire to contribute, excuse me, to somebody else's welfare or to a group, the highest
Mhm.
self-actualized need, the higher those were,
Yeah.
they
Yeah.
inhibited what was down below. And what this meant is you could get a
Oh.
sim who says, I am a doctor, I'm exercising my skill, and I'm saving a life. I don't care how hungry I am. Or I'm a mom, I will give my last bit of food to my child.
Yeah.
Um, so we had
Yeah.
some really interesting situations like that. Anyway, we were able to.
That is pretty cool, though. I mean,
Yeah,
that's neat that you're able to simulate, altruism and empathy. That's pretty neat. Yeah,
empathy was a hard problem for us for a long time. I mean, it's a hard problem for a lot of people, but
yeah, yeah.
you know, oddly enough, the ones that became the really hard problems for us were humor and deceit.
Hmm.
So
Yep.
humor turns out to have a like we are somewhat hardwired to have a sense of humor. Uh,
Exactly.
and so it's
Exactly.
not just it's harder to simulate it. And then lying to someone, if I'm going to lie to you, Ray, I have to have some model in my head of what you think and what you might want and what is going to be
Exactly.
effective.
Yep.
And it turns out that you can have sort of models 3 layers deep,
Hmm.
not just my model of you, but my model of what you think I want. And
Exactly.
and below 3 levels, it's like we just don't have the brain power to do that.
Yeah.
But modeling that in terms and saying I'm going to now tell you something that's false to get something I want out of you turns out to be just crazy difficult. So
Oh, it is absolutely the level of understanding that's required of my state, your state, and the state we want to be at some point in the near future.
right, I had a
Absolutely.
I had an AI researcher ask me, it was like 2009 or so, so 11 years ago now. He said, "Can two of your agents, these AIs, can two of your agents agree to meet for lunch tomorrow?" And I mean, that stopped me because I thought, well, I could make a let's meet for lunch engine. That's not that hard to do.
Right.
But if you want to make it general, you have to think about, well, what if tomorrow's Christmas? What if tomorrow is my wife's birthday? What if tomorrow we're all on lockdown because of a pandemic?
What if I don't like this person? What if
What
I
if
don't
I don't
want
like
to?
this person?
Yeah,
Exactly.
yeah,
What if I'm socially obligated, but I really don't like them? And so
exactly.
there's all these nuances, and that I think, at some level, still working on that problem.
Yeah, yeah. I think we all are. Yeah, absolutely. That I think that is a little bit of a tip of the iceberg to the general AI issue, right?
Yeah,
Because I really think
exactly.
that's where you start digging into those roots as to what it really.
Yeah, yeah,
For me, humor is another path to those roots, and insults. I think insults and sarcasm are other paths into that down that trail as well.
Insults we could do, interestingly enough. The AI that we built was largely built on emotions. So this is sort of an interesting thing in that traditionally AI has been emotions have not been considered an AI, and we have everything
Exactly.
from Data and Star Trek. He has no emotions. Well,
Yeah.
really, that was more about the limitations of the researchers of the time and
Exactly.
our poor understanding of emotions.
Exactly.
We actually built this to be primarily emotional in that you have
Mm-hmm.
these needs, and um, one of them is, for example, to be social and to be included socially.
Mm-hmm.
And so, if that's not being satisfied, then you feel lonely or excluded. There's a whole bunch of different emotions along those lines. And if I want you to feel that way, I can. The way an insult would work is to say, I'm going to transmit this thing to you. And it doesn't matter what it is. Just I'm going to transmit this bit of meaning to you that says you're excluded. You're less than
Mm-hmm.
me, and that
Exactly.
creates a feeling in you. So
Yeah.
that created a lot of that kind of emotional internals for the agents and their communication. Created a lot of really interesting situations for our AI.
Wow. So, in what ways were these agents being deployed? What did you actually do with this technology in terms
So
of
we built a
deploying it?
few simulations, and we built a lot of simulations just using this internally. I'll come back to this when we had our first instance of AI cannibalism, where two AIs ate another one by mistake. That was in. We, I'll come back
I'm
to this.
I'm really hungry, and I really don't like that guy.
More or less, yeah. But in terms of deployment, this was used by the military in some training for soldiers, as we used to say, training soldiers how not to shoot people. So it
Oh,
was
okay,
during the
okay.
Iraq War and just after that, but when they would have to be searching a lot of houses, and so we
Yeah.
wanted to train the soldiers on here is how things can go, but good or bad or worse. And so we had a whole bunch of AIs. All the soldiers were AIs, and all the civilians were AIs, and we had
Hmm.
them interact together.
Hmm.
And they had things like the soldiers had to talk to the head of household to say, how many people live here? Do you have any weapons? Things like that. And the head of household could decide to what degree they wanted to talk to this person, what degree
Yeah.
they wanted to be truthful. And we didn't really simulate lying. We had a fairly like if I don't like you, I may not tell you the truth, but it was fairly compact.
Yeah.
But there were some interesting things that came out of that. These AIs could also learn, and we actually had from a previous deployment we had put that in and just hadn't turned it off. And we had a situation where if the civilians got sufficiently scared, they would run away because it was just the escape valve, just run away, and that way we knew things had gone very badly. The
Hmm.
soldiers, of course, were not given the behavior to run away, and yet
Right.
one time we saw one of them running away, and we're like, "What happened?"
Whoa.
They did not have the behavior; it was not programmed into them. Well, we had left learning turned on, and what this one soldier saw was he evaluated his internal state and said essentially, "I'm very scared. Just recently, I witnessed someone else who was very scared do this action, run away, and she is now less scared. That now scores the best to me, so I'm going to take her action, and having observed it, I can learn it, and I will now run away too." And we had some very interesting things trying to figure out how to make the soldiers not run away no matter what.
Court
Um,
martial.
well, we had this idea. We had this idea already that one AI could suggest an action to another. And we said,
Yeah.
okay, a military order is a very strong suggestion. If you
Yeah.
do
Yeah.
this,
Yeah. Yeah.
eventually, if you do this, I will shoot you. And so what we said
Yeah.
was the orders they were under were if you get that scared, just go out to the Humvee out front and wait there. And that was a more acceptable. We had to talk to our subject matter experts about this, but that was an acceptable way to do it.
Sure.
But
Sure. Absolutely.
going back to the cannibalism thing for a second, what happened there was our first two agents. We naturally enough named them Adam and Eve, and we had a little bitmap picture of a cherry tree someone had gotten. So we scaled it up and we said, okay, that's our apple tree. And honestly, we did not think of the symbolism of Adam and Eve eating from the apple tree till sometime later. But
That's how deeply ingrained it is in our
it was just we
brains.
were just moving ahead. But so we created a third agent, Stan.
Mhm.
And each of the agents had different personalities. We created Adam and Eve with a very strong relationship to each other. Stan had a lot of social need, but not very much social ability. So he was not
Okay.
very socially adept and was lonely all the time.
Well, I can
And
relate to Stan totally. Yeah.
exactly, a lot of us can. And he really liked, and Adam and Eva, honestly, were kind of the cool kids, you know.
Yeah. Yeah.
And so he really wanted to be around them, and they really didn't like him that much. And we told him, we gave him things like, well, you need to eat, but we didn't tell him what to eat. So they tried for all three of them for a while. We're like, oh, let's try eating the tree. Well, that doesn't work. So they stopped eating that. Let's try eating the house we gave them. That doesn't work. They said, oh, let's try eating the apples. Oh, look, apples are amazing. Apples actually feed us. They reduce the hunger.
Hmm.
So we had a few bugs in the system, but what happened here was they said, let's eat the apples. So bug one was the apples didn't satisfy their hunger as much as it should. So they're eating and eating and
Okay.
eating and not getting very satisfied.
Okay.
So they ate all the apples. And the apples were
Okay.
generating slowly, but they ate all the apples. Uh, the second thing was that everything we hadn't initialized the weight or the mass of an object. So we had a
Uh,
sorry, this is too programming for some people here, but we had the super class was said the mass of everything is 1.0 just as a default. But we hadn't said humans weigh 200 or something like that.
right.
And we said when you eat something, you take half a unit away from whatever you had.
Hmm.
So the third bug was that when we had an association net, so that once Adam and Eve started eating apples, they associated apples with eating.
Hmm.
Unfortunately, because Stan was hanging around, they also associated Stan with eating. And the purpose for this
Oh,
was if I always have lunch with you and I'm eating lunch, I'm like, well, where's Ray? I always have lunch with Ray. I wanted to have that kind of association, but not I eat Ray. That was
yeah.
that was not.
Exactly. Yeah. 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 Yeah.
So so they ate the apples. They both said, well, we're still hungry. What else looks like food? Oh, look, Stan looks like food. They each and we happened several of us had to be watching it right as this happened. We had to sort of rewind the whole thing to figure it out. But they said, Stan looks like food. They each took one bite, half a unit each. Stan vanishes. And we're like, what just happened here? So we had some tools where we could go in and say, what were they thinking and what were their
Right.
intentions at any given time? We're like, okay, that looks good. Oh, no, that looks terrible. And,
That's a great story. Nowadays, there's libraries and
oh,
frameworks and all kinds of things you can just bring into play. And
things,
I've lost track of the technology that's available now. I really
such
have.
as
I
where we are today, if you are creating a game, you're almost certainly working either in Unity or Unreal.
Exactly.
Most indies are using Unity. It kind of depends, but there are enough. First of all, those are free or freely available. There's a payment
Right.
on the back, and if you start making a lot of money, great problem to have.
Right.
Um,
Right.
but,
Exactly.
but they have taken so much of the technical heartache out of it that it's kind of boiled down to we've made it really easy to make the game. Now, what game do you want to make? And that's the hard part. Even with AI, I have to say there are things like for pathfinding. Um, I have written what's called a navmesh tool for your agents to navigate the world, and that when as doing this, it's like this is not what I want to be doing. I'm trying to make a meaningful story, but I have to write this code here. Well, now it's like, oh no, turn the nav mesh on, and it's done.
It's done. Yeah. Yeah. Yeah.
It's like,
Yeah.
oh,
Exactly.
okay. Um,
Exactly.
Now, I still teach my students how to do pathfinding. There are some core algorithms like A star, for example, that they really have to know.
Yep.
Yes, there,
Yep.
there. You can get those
That's
tools.
fundamentals. That's fundamental to a lot of
Exactly. It's like doing your
search
scales
problems.
in
Yeah.
piano or something like that. You have to
Exactly.
do it. Yeah, yeah.
Exactly. So
Um,
now let's move into the present, right? We're talking, you know, my son just loves to play Grand Theft Auto.
yeah,
He loves Grand Theft
yeah.
Auto, with all the criminal activity, which is just so wonderful to hear him talk about, by the way. And then there's Call of Duty, and there's all these big, multiplayer games and whatnot. What is what is the what sorts of AI is being used in today's platforms that you've seen out
To some degree, there, like you was talking about, the fundamentals are still there.
there?
Every GTA NPC, Grand Theft Auto non-player character,
Yeah,
is and everything from that to Animal Crossing, the real new hotness,
yeah.
is they're all using A star or a variant of A star for saying I need to get from point A to point B. How do I do it? I'm going to go along this path. They're all doing those kinds of things. Um, what we see is the differences that have come about over the last 10, 15 years are some tools like behavior trees, task networks, and utility AI. Those are probably the big three. There are some games using variants of neural networks, but oddly
Mhm.
enough, neural networks have really never taken off in games. There was a
Well, they're very processor intensive. They're kind of expensive from a time and
you
processor
can you
perspective.
you can make them not that processor intensive. The problem is they're almost impossible to debug.
Oh yeah,
So
it's a black box.
yeah, exactly, exactly. So in fact, just a few days ago, or a week or so ago, Facebook was having a problem because they suddenly were marking a whole bunch of posts as being against their community standards. And it's speculation, but a lot of people have been speculating that what happened was they turned on a new AI, probably one that had used some machine learning, and what they figured out was, oh, the data set's bad because they turned it on during the time when all the COVID-19 stuff was coming up. And so they had to turn it off again because you can't debug it. All you can do is say, well, that data set is
Exactly.
bad. So
Exactly. You just train it again, and
exactly,
yeah, yeah.
exactly. So I have a lot of students who say, oh, you use neural networks. And it's like, well, there are parts of that that can be really useful. But anyway, the main things that people use are, like I said, behavior trees is a way of saying you want your NPC to be making um, viable decisions. I'll put it that way.
Right. Right.
And so they say, well, like I think it was Elder Scrolls Oblivion was one of the first ones to really do this in a big way, where they said, okay, given every hour of the day, they had a different behavior tree. So I wake up and there's certain things I do in the morning. So you wake up, you go to the bathroom, you brush your teeth, you get dressed. Um, that's a routine of behaviors that you might do. And then you say, well, now I'm hungry. I want to get food. So either I have food and I can make it, or I have to go buy food, or I have to go hunt in Oblivion. And so they have these
Mhm.
different trees that you can go down, but within each one you have sequences that you can follow to say I do A, then B, then C. Um, so that's very, very still a very common way
Oh, absolutely.
yeah, of making these characters look like they kind of know what they're doing. And
Mhm. Well,
we
that's essentially what we do with our Watson Assistant
right,
chatbot. That's
right,
it's
yes, yeah.
essentially just trees, lots and lots of trees, decision trees with nodes, and yep.
So there's something related to that called hierarchical task networks
Mhm.
(HTNs), which are actually really old. I mean, like 1960s, 70s,
Yeah.
kind of tool or tool set. Anyway, going back to frames, which I think from the early 70s, basically
Yeah.
saying it's an old classic problem. Um, Bob goes to a restaurant, um, sits down, orders his food, eats his food. Later, he leaves, and you could ask the AI, "Did Bob pay for his food?" Well, we never said explicitly that's what he did. But if you understand the process, the general routine of what it means to go to a restaurant, if you have a frame that has these like Mad Lib like slots in it, you say, "Oh,
Mhm.
well, he probably did because that's
Yep.
what you do at a restaurant."
Right.
So you can make frame like networks like that to say, I need to build a house or I need to carjack this person,
Yeah.
whatever it may be. I said,
Yeah.
how do I carjack a person? Well, first you need a car, okay, so you can do
Yeah.
that kind of
Yeah.
thing. The third technique is utility AI, and often with that influence maps. Dave Marks is a great guy in the games industry. He's done a lot with influence maps and utility AI. And this is what I was describing earlier with The Sims.
Mhm.
The great thing about this is that you can create maps, visual maps that do what's called spatial reasoning. So
Mhm.
in a war game, for example, like a strategy game, um, if there is an enemy unit out there, they're going to have an area around them that they're going to influence. Like that's
Right.
their danger space, is what it's sometimes
Yep.
called.
Yep.
And so, if I want my units, my AI units, to uh, do the best thing, they would look for like soft spots. Oh, look, there's two enemies here, but there's actually a path between them. And
Mhm.
so and as a human, you can visualize that as a map. It's like a heat map, and it
Right.
becomes very, very effective. Now, where things get really interesting is you can combine all of those together. So you can say things like,
Yep.
um, "I'm on a mission to." So I have this a network, task network. I'm on a mission to rescue these people, rescue this downed pilot. Say, to do that, I have a behavior tree that tells me what kind of behaviors I do in a given situation. Do I run? Do I fight? Do I hide?
Hmm.
And I also have a an influence map that informs me about the world, so I can say I can sneak into this window, get the pilot, and get out before the guards find me. So you can do some really fascinating things, and of course, it becomes as you layer these on, it becomes more and more complex. Um,
Absolutely, absolutely.
which is why game AI programmers walk around muttering to themselves.
Well, when you have all those complex tools that are, that all these algorithms that are working together, what's the overarching, executive control over that? What is it that decides? I'm going to listen to my heat map. I'm going to listen to my tree. I'm going to, what is it that? How is that decision made
you know,
inside the software?
yeah. So there decisions. There is a function that makes a decision, but often there isn't actually an executive controller. It gets a little bit strange. Um, what you have are so you can do this bottom up or top down.
Hmm.
Bottom up, you say things like with the Sims again, what in my environment corresponds to what I'm internally feeling, and then I can build a list of those things. And like the
Right.
executive controller for the original Sims was choose one of those three at random.
Yeah.
Um,
Yeah.
yeah. So a lot of these architectures will have what are called critics internally to say things like, you could go through that window to save the pilot, but the door is slightly less preferable, but is faster, or something like this. You have
Yeah.
this critic that isn't making a decision, but sort of adjusting the weights, and then the
Hmm.
final decision comes down to, well, this thing scored an 11.7, and that thing scored an 8.3, so we're going with the 11.7.
Yeah.
And
So it's like an evaluation function, basically.
exactly.
Yeah.
But
Yeah.
one of the
Okay.
keys is that each of these functions is very modular. It does only the thing that it does. So
Yeah. Yeah.
if I say I have a function that says leave the room, well, it's going to call another function that says get up and walk, and it's going to walk to the door. But the walk function has no idea why it's walking. The leave the room function has no idea why it's leaving the room. There's something else
Right.
that may have an idea. And usually it
Right.
comes back to some kind of behavior tree or something like that again. It says, well,
Hmm.
it's at this point of the day when we leave our room. So that's just because the programmer said so at
Yep.
some level.
Yep. Yep. Exactly. So I would imagine, like you said, these guys go around muttering to themselves a lot because it's like, well, I meant for this NPC to do this, but it keeps doing this. Why is that happening? And then you got to go in and start
Well, like
adjusting weights and yeah.
the situation I mentioned with the soldier running away,
Yeah.
we were stunned and like he clearly did not have in his repertoire. Looking at our we call it the telemetry tool would say he did not have in his choices run away, and he did. What happened? Oh, he observed it a few minutes before, and that became something now he could do. And so it wasn't something we intended, but we intended them to be able to observe their surroundings and learn from them. And we said, let's just turn off the learning.
Which is what you want a good soldier to do. Turn off the learning, do what you're told.
Exactly, exactly. There are some situations where that makes sense. Yes, yes.
Exactly. So what we've been focused a lot, I guess, in a broad sense on NPCs, right? Just
Mhm.
how are because when you go into an environment, you don't want to have the what was that platform called Second Life, where you
Second
go
Life,
in
right,
and there's like nothing going on, right?
right,
You're
right.
just there. You want to have a bunch of it. Is there any use of artificial intelligence to assist me while I'm in a gaming world? Has that ever been broached, for
There
example?
have been a few different ways. It's never really caught on, but there have been a few different ways. One, personally, that I love, and I still would love to do in a game, is that your character, while it's still your character in a game, has some AI of its own. So, for
Mhm.
example, in a game like GTA, what I would want to do is to say, um, my character is, right now it might be I'm a hired killer, but my
Mhm.
next character might be I'm a doctor. And
Mhm.
if I'm a doctor, I don't handle weapons. That's just not what I do.
Right.
So at some point in the game, you might say, "Well, I need to have my character pick up this doctor, pick up this gun, and shoot this guy before you kill somebody else." He's not going to be very good at that, and it's going to mess him up. It's going to make him very emotional.
Oh,
And
yeah.
so I have to understand
Yeah.
my character's emotional set based on their drives, based on the kind of character they are.
Yeah.
Um, and this leads to some interesting things. We looked at this in terms of creating like evil characters. I mean, frankly, like, something you might find in GTA. In a fantasy sense of evil, you might say, well, if you want to be an evil character, that means like you got to kill people fairly often, which is kind
Yeah.
of weird,
Yeah.
But you can't just say you're evil. We're saying now you got to be evil. And it's like maybe we don't want to do that in the game. One other type that a few other games have done is what's called director AI, and this is again
Mhm.
something that I've poked at and have seen a little bit, but not a lot yet. But that is um, having an AI that just sits and watches what the player does and tries to build the story around them. So if I'm in a game where I am constantly sneaking around, I could be walking, I could be sneaking, whatever. It's like, okay, the director AI says, I see you're sneaking. I'm going to give you some elements to play with that. So I'm going to spawn a cop character over here who might see you sneaking and chase you.
Ah,
Or I'm
okay,
going to give
okay.
you a room with an open window that maybe you can sneak in and see what's in there. Or alternatively, oh, you're chatting up all these people. Well, you're clearly trying to do a romance. So I will go in and we'll now turn this like a director, say, I'm going to direct this like almost like a film to be a little
It's
more romance.
like a dungeon master in a D&D game.
Exactly. Exactly. Yeah. Yeah. There have been a few games that have tried that. It's uh, I think Bioshock Infinity did a little bit of this, not a lot. They had some really interesting AI inside of the. Oh gosh, I think her name was Elizabeth. That sounds wrong now that I say it out loud. Anyway, some kids go, no, it's wrong. You got the. I know, I got that wrong. Anyway, they had some really good NPC AI, but they also had some director AI based on what the player did to change. And one way you see this is in like a difficulty adjustment. If you have a game where you have to make a leap over a chasm and you do it twice and you're just not making it, the third time, you know what? You're not going to notice this, but you're going to jump a little further.
Ah,
The
yeah,
game just helps you
yeah,
that way.
yeah,
And that's a
yeah.
perfectly valid use of AI. One of the things,
Absolutely.
and it really highlights, is that the purpose of AI, and believe me, developers sometimes forget this. The purpose of AI is not to make the best AI. The purpose of the AI is to make the player's experience the best possible.
Yes.
So if that means you
Yes.
get them over the chasm, it means you get them over the chasm.
Exactly.
Uh, yeah.
What a
But
lot of
there,
folks don't realize is, oh, go ahead, Mike, go ahead.
oh, no, I was going to say there are other stranger kinds of AI that we can use in terms of creating quest lines and world stories, but this is
Yeah,
really the bleeding edge at that point.
yeah, yeah, absolutely. So, what if, say I'm a young person interested in pursuing this line of work. How could how could I be, how can I end up in front of the great Mike Sellers as a student? You know, what are some of the things I need to focus on in high school or in middle school to end up being a developer that works with these sorts of AI tools? What
Well,
are the
first of all, I
skills
can
that you're
say,
looking for?
yeah, as I mentioned before, we are really sort of in a renaissance in terms of the availability of tools, and it's just there's so much you can do. There's so many freely available videos and courses. There are some that are not quite free, but are very, very good. There's a company called Udemy that I have no association
Yeah,
with, except that I bought a bunch of their courses. You can get them on
yeah,
sale for $12. Don't pay the $200. Um,
yeah.
what I found with them and like a lot of others, if you give them your email address, they will pelt you with emails, and you say,
Oh
"Oh,
yeah,
yes, I want that one on sale." Fine.
yeah.
But so what I would say is start learning programming, obviously, and I would say start with something like JavaScript, not
Mhm.
Java. They're two different things.
Right.
But JavaScript, there's an engine called Godot. It's Godot. It's a very good introductory engine. If you really need an introduction, Construct 3 is a visual way to learn programming that maps directly to JavaScript. That's what we do with some of our intro programming courses. If you have done those, you have some programming already, you can leap in with something like Unity is a fantastic tool to use.
Yeah, yeah. It
Um,
is.
I get questions a lot about Python. Python is just not used in games very much.
No.
Um, it's not a bad language, and there are things like Pygame, little environments you can use. But really, if you're going to do something, you must just go straight. Get to Unity. Whether you go straight there or get to Unity, there's really no reason to use Unreal to start with. If you get really good at all of this, then yes, you could explore Unreal. Um, I will say with Unreal, there are the Unreal Editor. There are some amazing things you can do with what they call blueprints, but they're not really programming. And what we have discovered in our own teaching is that you can do a lot with blueprints just for hooking these things up graphically on the screen, and it's terrific. But then you get to a point where you really can't do anymore, and now you need to learn some serious programming. So there's this shallow learning curve that takes a big jump. So I would say
Yeah.
use Unity first. Really, get into it. I have a suggested high school curriculum for game designers, but a lot of it applies for game programmers as well.
Oh, wow. Okay.
I can give you a
Okay.
link to that.
Yeah,
Uh,
that'd be great.
um, The other thing I would say is just make a game, make something very very small. Get used to the idea of making and finishing something very small. So make Pong or something, but make a game that you can actually play. Um, then there are a ton of online resources. There's a couple of game AI channels that I can send you links to. There's a site called Red Blob Games that
Mhm.
a fellow named Amit Patel has been putting together since he was a student at Stanford, and it is still the go-to reference for game developers and AI developers everywhere.
Wow.
It's just
Wow.
it's one of these things that he's a wonderful person. He's done some great things and said, "Here, I'm making these things freely available." But for example, if you say, "I want to understand A star," he has, and there are other really good ones out there as well. But he has a really good tutorial on A star. And as a young person, if you're trying to get into programming, I wouldn't say start with A star. It's a little bit more complicated.
Right,
But once
right.
you're ready for, you say, "I want to have this person go from here to there a little bit better." Um, you can start exploring some of these ideas.
Right.
And like I said, there are just innumerable free videos, tutorials, and things, as well as classes online. I will mention Penny DeBill. She's a professor from Australia. She has a couple of Udemy AI courses that I've taken, and just to sort of like see what's happening out there. And like, these are amazing. Her production values kill me. It's like I was thinking, oh, maybe I could put one of these together. And like, oh my goodness, what she's done. Or
Yeah, she's like in the Australian Broadcasting Corporation, with all
yeah, yeah, really good stuff, and
yeah,
and really good content, I should say. So, all those things are worthwhile. And I will say this is a terrific time if you are. I will absolutely say this is not a boy thing. So if you're a young woman,
exactly. Yeah.
this
Yes.
is for everybody. We really emphasize that
Yeah.
in our program here. Unfortunately, we have a lot of women coming into our university who say, "Well, I've always liked games. So I didn't know if I could do it," and we really welcome them in. And so we
Yeah.
really strongly look for people of different ethnicities and backgrounds and
Yeah.
genders and religions and everything. The reason being that the more diverse views we have, I mean, I can show you this quantitatively, the more creative and better output we have.
Absolutely, because you're dealing fundamentally with the human condition, with
Exactly.
simulating the human conditions in real life, and you're not gonna get that just if you just hired white Mormon guys.
You know,
You'd have a great white Mormon game, but
exactly. Yeah, so no, I tell my students, I say this is not just for guys, it's not just for white guys, it's not just for cis male white guys. It's we really look for
yeah,
everybody, and
exactly,
that is
yeah,
more
yeah,
and more true just across the board. And certainly with something like AI and I mean, games in general, but AI in particular, if you can do this, if you're interested in it and you're willing to put in the work, there is just really no end to what you can do.
absolutely. And I think now, I mean, right now we have a lot of kids that are stuck at home because of the COVID-19 issue. And
Right.
it's actually a really great time to start picking up something like this because picking up and learning how to do a game design and game programming and AI. It's a never end. It's the gift that keeps on giving. You're gonna hit one level, you're gonna finish that level, and there's gonna be another level. There's always another level that you can mine. Always, 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 always. So
Exactly.
yeah.
The one caution I will offer that I always give to students, and they don't like hearing it.
Right.
Even my advanced students don't like hearing it. Don't say I want to make game AI because I want to make a huge
Yeah.
MMO or I want to make realistic human interactions. Don't start there.
Right.
One thing you
Exactly.
can start with that's actually really interesting in terms of AI is create a small 2D world. It just a bunch of like a grid or whatever you want, and if you're using Unity or Construct or anything, and make some sheep and some wolves
Mhm.
and make it so that the sheep like to eat grass and like to stick together, and the wolves like to hunt the sheep. How can
Exactly.
you make that interesting? And how can you give them the final part of this is how can you give the player something to do? Could you put a sheepdog in there, for example, that is trying to protect the sheep from the wolves? Suddenly you have a game. And you can
Exactly.
make that out of very simple components. So I would say you start with, I want to make a sheep. That's all I want to
Yeah.
make.
Yeah. Yeah.
And
Exactly.
once you have that, you
Exactly.
can make 10 sheep and then go on from there.
Exact. Yeah. I learned the lesson the hard way when I first got into it years ago, 30 years ago, was a build a HAL 9000.
Yep. Oh, we've
And
all
now
done
I'm at
this,
this
believe me.
Yeah. Now I'm at where if I could just get some good output out of my NLP algorithms that makes sense, I'll be happy. Well, Mike, listen, thank you for your time. This has been a great conversation. I think I've certainly learned a bit listening, and I hope the audience has too.
Well, thanks very much. It's really been a pleasure. It's great talking to you about all this stuff, Ray. And I'm really looking forward to seeing what the students who are, 10, 11, 12, 13, 18, whatever, what they come up with in the next few years. I think it's going to be amazing to see.
It's going to be amazing. It's going to be amazing. We got a lot of really smart kids out there that I express their creativity, and I think, and
Exactly right.
this is a perfect way to do it.
Very much so. Yes.
Well, listen, Mike, again, thank you, and hey, wash your hands.
Yes. Exactly.
6 feet, 6 feet,
Right. Right. Right.
and stay safe.
All right. You too, Ray. Thanks very much. It's great talking to you.
Thank you. It's great talking to you too.